Assalamualaikum warahmatullahi ta'ala wabarakatuh. How are you? How's everybody? Okay?
Alhamdulillah, sir.
Alhamdulillah. Mana? Ramadan. How's your Ramadan? Small fine. Okay, you know what? I have to inform you about our reschedule makeup class. On Sunday, I couldn't make it. So what we'll do, we'll have the makeup class after the break. After the break, and lepas raya, I will do the makeup class. But before the raya, before the break, we'll have our test, our midterm. So I will inform you some detail about the test. So that will be my announcement for today. So number one, okay, what I would like to share with you, okay, announcement. Number one, the makeup class, I will make it after the break. Okay, after the holiday. Now, number two, we'll have our midterm 2 weeks from now. The only day that is available for everybody will be Sunday. So we'll make it on Sunday, the 9th of May. And the time is 10 a.m. So I think there will be no excuse, for not being able to come to the test because it's on Sunday. I don't think anybody has a class on Sunday. Okay, I want to make it on Saturday. Some people even have classes on Saturday. And Friday also, so the only time is Sunday. Now, anybody has a class on Sunday? 10 a.m. So I think it should be okay. Now, the coverage should be from the topic 1. Apa saya ada? Saya ada bunyi macam, okay, the coverage is from the first topic, okay, first topic on linear function up to what we are doing now, that is on the partial derivatives. So those are the topics that will be in the test. Okay, all right. Any comment? Any question? Anything?
How long is the midterm?
How long midterm? Don't worry. Okay, I will tell you after.
That's mean that.
But okay, at least it would be one class time. That means 1 hour and 15 minutes, like that. That's the minimum lah. And it depends on the number of questions. So normally midterm, we don't have a too long midterm, it's not a final exam. So like one class time, right? Maybe longer lah, not more, not less. Okay, all right. Any other question? Anything else? Okay, so for your practice, you may look at some exam, from last semester. If you know some people who took the test, who took the course last sem or the sem before that, those people who took it online. Okay, so maybe you can try, look at the past semester question. Okay, so today what I will do, we will look at 14.3. And that is on application of the partial derivatives. And then I will move on to 14.4. We're going to do the second partial derivative test, just like the second derivative test. Okay, second partial derivative test for maximum and minimum. So hopefully, I can at least cover some of this today. Now, application, I would like you to move to look at 14.3. Look at example number 1. The example number 1 on 14.3 is about cost function. So can you go and look at that example? I want you to read, okay? Read that example for 1 or 2 minutes because you want to see, the variables and the form function. So go through that example. It's a fairly short, explanation. All right. Okay, good. So example number 1, it's about cost, okay? Cost function, where the cost to the firm, cost of producing 2 products, X and Y, is given there. So here you apply the function with 2 independent variables, and we are interested in taking the partial derivatives. So if you look at the function, your z equal to f of xy, and the partial derivatives are zx should be equal to, not comma, equal to f of x, okay? Or in terms of the partial derivative, when you do application, you want to look at the change, all right? So you think of it as dy dx, I'm sorry, not dy dx, dz dx, or df dx. Okay, dz dx. That means a small change in x, then what is the change in the function in z, the dependent variable? And that is given by the partial derivative. Now, when you do application, we just like the previous topic, we think of it as delta z over delta x. So here, you want to look at what? 1 unit. Okay, 1 unit increase in x, then what is delta z? Okay, and that delta z is given by what? Is given by the partial derivative. Zx. So in application, we go back to our basic interpretation, which is this one. So 1 unit of x, and then what happened to the dependent variable, and that is given by the value of the delta z, which is what? Which is partial derivative lah, which is the slope. Again here, that is the slope at a point. Okay, so that is our idea. And similarly for the other partial derivative, so you got zy, that is equal to fy. Again here, you think of it as delta z over delta y. So now you have the variable that is changing is y, and then delta z is the change in the function, correct? And that is, of course, given by the value of the slope at that particular point. Okay, all right, so that is our idea. Now, if you look at this example, you have cost. And cost, we already did cost. All these examples are common things. The only difference will be what? Will be there are functions of 2 variables, okay? So you got a cost is a function of x and y. And cost is C in dollars. Okay, that one we know already, the unit. Now, what are the variables? The variable is X. First one is good 1. Okay, so here quantity of product or good. Okay, here they just say X. So let us be more specific. Okay, now I think if you look around you, most of the firms, all right, or business, they produce not a single product, okay? They produce 2 or more products. So you tell me one company that produce at least 2 products. Real one, not imaginary company.
Samsung, sir.
Apa dia?
Samsung.
Okay, Samsung produce apa benda?
Smartphone and watch.
Okay, ada watch
Ada watch, sir.
Okay, so Samsung, okay, good example. Samsung they produce smartphone, okay, smartphone, and the other one watches, okay, hand watches. So you call that X, we call the watches Y. So here we are talking about the company Samsung, the product, the firm, and produce quantity of product. So the product is the first product, which is the smartphone. Okay, quantity of smartphone, SP in units. Okay, unit means one piece. And then Y is the quantity of the other product. Okay, quantity of the other product, which is watches, and that is also in unit. Okay, unit means another piece of what? I don't know what is the English language. Penjodoh bilangan kepada watch ni dipanggil apa? Piece. I think piece. Okay. So we just call it unit. Okay, 1 unit of watch. And the cost is given by, if you look at that example, is given by the function, and the function is fairly simple. So we got C. Okay. C is equal to 50 plus x squared plus x squared plus. Everybody see that example? Okay, I'm not going to write the function. It's too long, a bit long. So now what you want to find is, you find the marginal product. Okay, find the marginal cost. So if you recall, when you look at marginal cost, what does it mean? Same thing, same concept. Marginal cost, what is it?
The first derivative.
Your first derivative. Okay. So here you have two variables, x and y. So you have two marginal costs. One is marginal cost, MCX. So we call that marginal cost with respect to x. Okay, with respect to x. And there is another marginal cost because there is another independent variable, MCY. That is the marginal cost with respect to y. All right. So marginal cost, the idea is still the same. It's what is the change in cost per unit increase in the independent variable, either x or y. And of course, we're going to look at the description later on. Okay. All right. Now, you want to evaluate this at a certain level of output currently. Okay. Let's say as of now, they currently produce. Okay, they produce how many units of handphones? Let's say, just not make it so big number, okay, but not make it so small. Let's say they're producing 500. All right, 500 units of smartphone. And watch is fairly simple to produce, okay, relative to smartphone, I think so. Let's say 800 units of watches. So let's say that is the point now. So you can say that at 550, 800. So you can say at 500 and 550 and 800, you find the cost. Okay, right. That's number one. Number two, you want to find the marginal cost. So marginal cost, I remember last time we tell you, marginal means derivative. So here marginal cost x, MCX, marginal cost with respect to x. What is it? Derivative of what? With respect to what? Derivative of the cost function with respect to x. Okay, what is the derivative? Anybody? Just give me the derivative now. Okay, we go term by term. Okay, what is the first one?
0.
0. Okay, after that, 0 tak payah sebut. Okay, from now on, 0 tak payah sebut. Okay, we go to the non-zero number. Okay, first one, what is the first term?
2x.
2x, okay? X squared, derivative with respect to x is 2x plus. Okay, what is the second term? 8y, okay? And then y cube is 0. And then you look at MCY, the derivative of the cost with respect to y. What do you get? You get, okay, anybody? Cepatlah. Bukan weekend, I give you a lot of questions, practice. Takkan seorang pun tak buat ni.
8x.
8x plus
3y.
3y. Oh, not 3y. You missed the power. What is the power?
Squared. 3y squared.
3y squared. Okay. So for those people who still are not sure, you have to do a lot of practice. Okay. If you wait until 2 weeks from now, it's too late already. Okay. So make sure you do. If you don't do, then we have a problem. Okay. So you got this thing here. All right. Now we already do this thing. Number one, you find the cost, all right, at this level. So I want some people to do the cost. Okay, if your name is from A to H, okay, find the cost. Now, if your name from I to N, okay, you find MCX. If your name, no, N, M. Okay, and your name from N to Z, okay, you find MC1. Okay, do it now. 1 minute. Evaluate the value at the point that I stated earlier. 550, 800. Okay, so that we can save time. Some of you find the cost, some of you find the MCX, and then you find the MCY. Okay, anybody get first? Let me know. Whatever the which one doesn't matter. Then tell me how you get that answer, all right? Okay. Anybody who get it? Cepatlah. This one I don't have to call name because I group already everybody into doing this thing. All right. MCX, MCY, and then the C. Okay, Sajat. MCY, you are supposed to do the MCY. What is the value of the MCY at that point? Okay, somebody help him. What is the value of MCY at that point? Anybody? Takkan seorang pun tak dapat.
So do we need to put X also there? Because it's only respective to Y.
No, that's why I said find the value. After that, we discuss. Okay. So
okay.
whoever get it, doesn't matter whether it is wrong or it is right. I said find the MCX and MCY. After that, we discuss. Okay, what is the value that you got? Tell me.
What I got is 8x for MCY, 8x.
MCY, 8x. So you evaluate
8x,
at the point. Okay. Okay, 8x. 8x plus
8x plus 1.
Huh? Plus 1.
2, 8, 0.
Oh, you already
There's a lot
multiply.
of-
Okay, you don't multiply now. Just
Okay.
substitute. So 3 multiplied by what?
3 multiplied by
800 squared.
squared.
Okay. Now, is this correct or is this wrong? Bawah zero. Is it right or is it wrong? Oh,
Wrong.
okay. What should be the right one?
We include the X also.
You have to include the X. Okay, you are not wrong. You are half right. Okay. So what you need, you have to put in the X. Because why? Because there are two independent variables. And you evaluate at a point, which is what? 550, 800. So you have to put the X. What is the X? 550. So the correct one should be what? The correct one should be 8 multiplied by 500. So you are not wrong. Okay, you are right. Half right. So that's a good try. So you got 8 multiplied by 500. Okay. So now if you do that, what will be the value? Okay. Now MCX. Anybody got MCX for the names AI to M tu? Siapa dapat? Siapa dapat?
7,500.
Okay. How do you get 7,500? Tell me the step first.
2
Okay.
times
2.
550.
So 2 times 550. Oh, I'm sorry. That X is 550, cannot 500. So that would be 550. So 550 plus 8, 800. Okay, good. So what is the value today? 1700.
7,500.
7,500. Okay. Now for the MCY, the marginal cost with respect to Y after you put in the value of the X. So what do we get? Berapa? Okay, yeah, finish up. All right. Now we go to the first one. Okay, the cost. What is the cost at that point? So how do you get the cost? Anybody from A to H? Cepat lah. Saya tolak. Okay. Fazlina. Okay, what is the cost? How do you get that cost? Fazlina, are you here? Okay, anybody? How do you get the cost?
Just substitute X and Y
You substitute X and Y into what?
into the function.
Into the cost. Okay, so you substitute X and Y, which is 550 and 800 into the cost function. So you do that. What is the value?
Have a calculator.
Do now. Calculate now. Okay, Zuhra, what is the cost? Oh, I'm sorry. It's not you. You are not supposed to do this one. Okay, get me the value. Fatin. Okay, Fatin. What is the value? Cost. Okay, anybody? Because we substitute the value, the value of X and Y into the cost function. So you will get the cost. Okay, what is it? Anybody have done this? Hai, nampaknya. Cepat. Because I don't have calculator. Okay, you have to do the calculation. All right. Cepat.
4,
4,
6, 2,
6,
5, 5, 0.
6, 2, 5, 5, 0.
5, 5.
Itu dia. So it is 4,462,000 and 550. So that is the cost. Everybody got that? Is that right? Okay. So that is the cost. Okay, that's the cost of producing 550 units of the hand smartphone, 800 units of the watches. All right. Now you take the partial derivative, you get the marginal. The marginal means you have two marginal. The marginal with respect to x, the marginal cost with respect to y. That will be what? That will be the increase in the cost or the change in the cost due to what? Due to 1 unit increase in the independent variable, either x or y. Okay, now MCY tadi berapa? Anybody? Saya tak tulis lah tadi. Berapa MCY ni tadi?
I got sir 19,
19,
4,
4,
2 and 4. I mean 2 4 1924.
1924,
Yes. 4
4,
0
0.
0 0.
Ada lagi
Double.
0. Okay. So you see here, is this correct? Okay, tak apa. So you see here, the marginal cost of the y and x, they are different. Of course, they're different because it's non-linear function. Now, what is the MCY, MCX? So how do you describe it? All right. Now, you describe it as what we already did. How do you describe it? First, you need to determine, or you have to state at the point of the derivative. So at 550, 800. Or you can say, given currently the cost, given the currently the firm is producing, or given currently Samsung is producing 550 units of handphone and 800 units of watches, okay? Or to put simply, just at 550, 800, if what? What is the one that increased now? What is the one that changed? Is it handphone or is it watch? What variable? If Samsung produce, okay, one more unit of what? One more unit of handphone or smartphone, I'm sorry, smartphone, then what? The cost will increase by how much? The cost will increase by $7,500. Okay, so that is our basic interpretation. Nothing different. All right, that's like what we were doing on the derivative topic. So here, okay, here is if x increases by 1 unit. So that is the point. If x increases by 1 unit, or you can say if smartphone increases by 1 unit, then what? Then the cost will increase by $7,500. Okay. Now that is not the full description. We have to state what? You have to state that the other variable is constant, given. What is the variable that you keep constant? That is what? The watches. Given y, which is watches, constant or fixed at the level that we are given, 800 units. Okay, so here for the partial derivative, the addition that you need to state, the additional statement that you need to do is the other variable constant that you have to state. Okay, so given the watches, which is y, fixed at 800, or maybe constant sound better. okay, or the watches constant at 800 units. Okay, all right, any question? Okay, now I want you to interpret MCY using the same concept or the same intuition, okay? First, you have to say the point of the derivative and then describe the derivative. So the derivative is just like the slope. And then say that the other variable is constant. Okay, now I want you to write down the MCX. Okay, you got it? So for the MCX, so again here, you have to state the level of the current level of production, okay? So you say at 550 and 800, if Y increases by 1 unit, in other words, if they produce one more unit of watch, okay, one more unit of watch, which is Y, then what happened to the cost? The cost will increase by $1.92 million. Given what? Given the other variable constant. What is the other variable? Handphone or smartphone, I'm sorry. Given the number of smartphone constant at 800 at 550. Okay, so the one that is increasing now, all right, is watch. So they produce one more watch from 800. They produce one more. So that is the increase in the cost. And the number of smartphones do not change. All right? Okay. So I hope everybody will get that. Okay, now we move on to the second example. Now the second example is example number 2. It is on the harvesting. So here, you look at the crop, okay, a crop that is harvested according to the function. So I want you to read that example number 2. Harvesting is like producing, okay? It's like production. So you want to harvest, that means the quantity of the harvest or the amount that we produce is depending on what? It's depending on the inputs, which are labor and land. So here, all right, the crop harvest, crop, which is, okay, tell me, give me one crop that you are familiar with, rather than say crop, then we give a specific name of the crop. What?
Corn.
Tak nak corn, pagi tadi dah corn. Petang ni tak nak makan corn dah. Petang ni makan benda lain pula.
Palm.
Ha?
Kelapa sawit.
Kelapa sawit. Boleh lah. Kelapa sawit, palm oil, okay? Oil palm ke palm oil? Now that this already become minyak, okay? This already minyak dah. Okay, it's becoming the oil. So oil palm, not palm oil. So oil palm. Now oil palm, people are complaining. Oil palm harga dah melambung naik, betul? Because
Yep.
because I haven't since because I bought a big bottle of palm oil, minyak masak lah. I cook not so much. I bought that before they changed government, okay, or maybe at the beginning of PN government. So now people complain the price of oil palm oil. Palm oil to oil palm. The price of palm oil is already like double. Look, okay. So now the new government, the price is rising faster actually. So you have the crop, okay, palm oil. Now we maintain the unit, which is in bushel. Okay, so the bushel here, even though it's liquid, it can be kept in bushel. Okay, so we maintain the unit So the palm oil, the crop, it is bushel. So that is the variable, dependent variable Z. All right. And then you have the independent variables X and Y. Now X is what? Is labor. Okay. So if you look at here, the unit of labor is work hours. Work hours. It's not in units of labor. It's not in physical units of labor. It is in hundreds. Okay, hundreds of hours. So the unit is hundreds of hours. So in other words, if X equal to 1, actually it is what? It is 100. So 100 working hours because the unit is 100. Okay, all right. So Y is what? Y is land in acres. So that is the dependent variable, the crop, which is palm oil, and then you have the labor and the land. And the function is given, okay, by that function. So now we are talking about crop, okay, which is, think of it as production. Sometimes we can think of it not as Z, we now sometimes we can write Q, okay, Q for the dependent variable. So Q is the quantity of the palm oil. Sometimes you can write Q, for production. And that is equal to whatever the function that you have. Okay. Now we take, again here, let's say at the point where you have 200, okay, 200. So 200 meaning 2000. No, 200 is not 2000. If what happened with the 200 were used on 3, okay, if it is 200 hours, then you will say just 2, okay? So 2 hours, 200 hours, and what? And 300 acres. So at 2 and 300, okay, number 1, you find the Q, okay, or Z. Okay, that's number 1. Number 2, you find the marginal product. Okay, marginal productivity of X, you call it MPX. So the marginal productivity of X, you call it MPX. If you read the book, they call it marginal productivity of X. Okay. And then number 3 is the marginal productivity of Y. Okay. So that is the partial derivative with respect to the deep independent variables. Now, let's actually for this function, they didn't do anything. Okay. They didn't do the calculation. So I'm going to give you this question as homework. So this question, homework, you go home, you do. All right, that means I want you to do 1, 2, 3, add 2, 300. And also you interpret. Okay, interpret the value of the marginals. Okay, all right. Now the function is quite, it's not as simple as what we think. The sample, you have to use a quotient rule here. So here use quotient rule. So you need more time, we cannot do it in class. Okay, so I want you to take your time, do it at home. So that is example number 2. Now related to that is example number 3 and number 4. So we are doing now the proper production. So when you interpret this example, okay, we do example 4. So the interpretation, you can apply to example number 2, okay? So you can apply. So now we are going to do example number 4. So here you are looking at production function. So again here, production means you produce a good, for example, a crop, which is palm oil. And that, in order to produce the quantity, that will depend on what? That will depend on the inputs. So the input are, if you look at that example, the inputs are normally will be what? Will be labor and some other inputs such as land or capital. So I want you to read example number 4. Okay, so spend 1 minute. Okay, read that thing and then we will go through. Okay. So here, production function, they call it. Normally, this kind of function, they call the Cobb-Douglas function. The Cobb-Douglas is very common in economics. We write production function, utility function, in this form. Now, generally, this function is this form. Z equal to A multiplied by X to the power of alpha, Y to the power of beta. So A, alpha, beta, they are all constants. And they are bigger than 0. Okay, they normally don't, they are not negative. And Z, or for application, we're going to use Q, but here, the general form is the dependent variable. In production function, we call it output. Okay, output unit. And then X and Y are the inputs. So normally the inputs are capital, okay, in units, and Y labor in units. So that is the general form. So if you look at the example number 4, you have here the function Z. I can write Q to denote the quantity equal to 100 X to the power of 1/4 Y to the power of 3/4. So that is an example, all right, or the application question. So you have that example. Now, if you look at that example, what is Z? They didn't say what is Z, all right? So we go back to our example, which is the cost for Samsung. So, so now we cannot think of Samsung as the quantity of the output, smartphone and watch. We can only think of it for one output, okay? So again here, if you refer to the Samsung example, then Q, okay, will be what? Will be the quantity of what? Of one good only. Quantity of smartphone in units. And to produce the smartphone, they will need what? They will need capital. Okay. So here, X is capital in units. Now I'm going to move away. I'm going to depart from the units in the book. We just say units. All right. Unit here means physical unit. That means one machine, two machine. Okay. If there is one machine, we call it one machine. It's not in terms of the money value. Okay. We just say one unit of machine or 2 unit of machine. So the unit of machine is the physical unit, not the amount of dollars. Okay. And then Y, again here, Y is labor. We are not talking about labor hours. I just use unit. Again here, the physical unit of labor. That means 1 worker or 5 workers. Okay, it's just the number. Okay, the number of workers. So labor in terms of unit or the number. Okay, so that is the variables, or that are the variables and the units for each of the variables. Okay, all right. So now what you want to find is you want to find the marginal productivity of X. So marginal productivity of X is the marginal product of what? The marginal product of capital. And then you want to find the marginal product of labor, the marginal productivity of Y. And then you want to interpret those. So we are not going to answer the question as per exactly in the example. We just do it as our previous example. You find the partial derivatives, and then you interpret. Okay, to draw is quite difficult because it's 3-dimensional graph. So again here, I want everybody to do it. Okay, first, find the MPX. All right, So if you are from A to M, find the MPX. MPY, you are N to Z, okay, get the MPY. Okay, do it now. The marginal productivity, that means you take the derivative of the function with respect to the particular variable. Okay. Okay, anybody get either one of these, let me know so that we can get the answers and we move on.
Sir,
Yes.
I got MPY.
Okay, what is MPY?
100 multiply
Okay, MPY is equal to 100
multiply 3/4.
multiply by apa?
3/4.
P over 4.
3/4.
Okay, P over 4.
3, sir, 3.
Oh, 3 over 4. Okay, 3 over 4.
Y,
Y,
negative, power of negative 1/4.
for Y, you have 1 over Y to the power of negative 1 over 4. Okay,
X to the power of 1/4.
X to the power of 1 over 4. Okay, right. Apa dia tadi? Tadi faham? Okay, you got this. Now, everybody, not everybody lah. Those people who do from N to Z, berapa, is it true or is it not right? Is it right or is it wrong? You are taking the derivative MPY. That means take derivative with respect to Y. Okay, anybody from this group?
Correct, sir.
Correct. Is it correct or is it not correct?
Correct, sir.
Correct. Eh? Anybody who say wrong? Okay, but Wazir, is it wrong or is it right? You are not doing this one, but
Doing the first, sir.
huh?
I'm doing MPX.
I know, but is it right or is it wrong?
It's right.
Okay, anybody who say wrong? Huh? Is it right? Right. Yeah, that's right. Sorry. You know what? I was looking at the other function. So actually, that's correct. Okay, I'm sorry. I was wrong. I was looking at the other function. I was not looking at that function. So actually, I got the wrong function, and yours is correct. So the function, okay, the function was 100 because I didn't see the function here. 100 x to the power of 1 over 4, y to the power of 3 over 4. So you are taking derivative with respect to y, all right? So the x is the constant, okay? So the x is the constant. So one way to do this, okay, this is correct, all right? What I do, I will just describe it. MPY is equal to what? The x is a constant. So you got 100 x to the power of 1 over 4. That's a constant. Okay, you put the bracket to the constant terms. The x over 4 and y. No, not y, and 100. The only variable is y, and y is to the power of 3 over 4. So you take the derivative of that, you got 3 over 4. Y reduce the power by 1, so that is 1 over 4. Okay, and then of course, simplify. You get 75 x to the power of 1 over 4, y to the power of negative 1 over 4. Okay, so one way to single out the constants, you put in together the constants. Think of it as one constant only. Okay, now MPX. What is the value of the MPX? Not the value. What is the MPX? Anybody?
100y
100y.
power of 3/4.
Okay. So here, we put the y, which is the constant, together with the 100. Okay. And then you differentiate that's x. That's one good way to do that, the derivative, for this kind of function. But after you master already, kita dah buat banyak masalah, then so you don't have to do this. All right. But this is good way. Okay. Okay. Then you take derivative of x to the power of half. You get 1/4 x to the power of 1/4 minus 1. What do you get? Negative apa? Negative 3/4. Okay. So that is equal to 25 multiplied by that. All right. Okay. So one last thing that I want to look at. We want to find, okay? You want to find the value of these marginal productivities. So what you do, you can bring the y, which is the negative power, to the denominator. Similarly for the MPX, the negative power, which is x, you bring it down. So I will write down here. So you got 75 x to the power of 1/4 divided by y to the power of 1/4. And similarly here, you got what? 25 y to the power of 3/4 divided by x to the power of 3/4. So that will be easier for us to compute. So now, I want you to find the value, okay? The value of this marginal productivities, given that function, the output is smartphone. So given at a certain level of capital, let's say now we are looking at 10 machines, okay, 10 units of capital, or 10 units of machine, and then 25 workers, all right, 25 units of labor. Then, right, I want you to find, okay, A, MPX, okay, B, MPY. That means we already have the function. Okay, I already have the function here. This one. So I want you to evaluate, okay, at 10 and 25. So again, your name from A to M, you find the value of the MPX. If your name is N to Z, you get the value of the MPY at that point. So do it now. And after, okay, anybody who finished your value, you find the value of Q. Okay, put in the function. So Q, everybody do. If you finish yours, then do Q. Okay, do it now. Okay, anybody who get first, let me know. Either MPX or MPY ke Q ke, doesn't matter.
Sam,
Yes.
I got MPY.
Okay, MPY, what is it equal to? So when you do the MPY, okay, so MPY, that will be equal to, substitute into the function, okay? a function MPY, not the original function. So you substitute into 75, okay, equal to 75, all right, X, which is, I didn't write the value, I'm sorry. X is 10, 25. So you got 25 to the power of 3/4, 5 to the power of, apa tu? 1/4. 1/4. MPY, X is MPY, I'm sorry, MPY. Kita dapat MPY dulu . So X is actually 10 to the power of 1/4. No, that is not right. So should be, right, 10 kan? 10 to the power of 1/4 divided by the Y, okay? Y, which is 25. So 25 to the power of 1/4. So that's how you get the value. All right. Now, what value do you get?
59.65.
9.65. Okay. All right. Now, MPX. Anybody got MPX? Okay. Right. Anybody got MPY? I'm sorry, MPX.
390.6.
So you put in the function, okay, the MPX, which is 25, all right, multiplied by the amount of the labor Y. So you got 25 power 3/4, okay, divided by 10 to the power of 3/4. Is that right? So that's how you get the MPX. So equal to berapa tadi? Can you repeat again?
390.6.
390.6. Okay, is that correct or is it wrong? Somebody else check. Okay, for those people who are doing the MPX, is it right or is it not right? Betul, So both are correct. Okay, good. Now get the Q, the output level at the point. So you substitute into the original function. Okay, 10 and 12. No, 10 and 25. So what do we get? So you have 100, okay, x to the power of 1/4, that is 10 to the power of 1/4, and then you multiply by y to the power of 3/4, which is 25 to the power of 3/4. Okay, you do the calculation. Anybody get the value yet?
I got it, sir.
Okay, okay, share.
1988.18.
1988.18.
Yeah.
Betul? Okay. Anybody got it? Same? All right, good. So we assume that's correct. Okay. So currently they are using or they are hiring 10 units of capital or machines and 25 workers. They can produce how much? They can produce 1,988.18. So you can round out to 1,988 units of smartphone. Okay, so that is the level of production. Now you want to look at the change. So you can interpret MPX. Now, how do you interpret MPX? Anybody? We already do the cost, okay? So I will do the MPX and you will do the MPY. So here at 10.25, if X increases by 1 more unit, what is X? Capital. Okay, if we hire 1 more unit of capital, or just simply capital increases by 1 more unit or by 1 unit, then what happens to the output? Output will increase by how much? By the value of the marginal productivity of X, by the X. So output will increase by how much? 390.6 units. Now, what variable do you keep constant? Keeping what? Labor constant at what? At what point? At
25.
25 units. Okay. Okay. So that's similar to the cost. Okay. It's just about what? Just about the change. Okay. So first you have to state the point where you take the derivative, and then you state the increase 1 unit of the independent variable, and then what happened to the function, and that is given by the value of the marginal productivity of that particular variable. And then the other variable constant. So this is MPX. All right, now I want you to write down the MPY. Okay, do it now. I give you 3 minutes to write this down. Okay, now there are still people who do not put the pictures here. You know, I do not know how many times do I have to say this. There are still a few people. Ni Muhammad Dafar, ni Fazli. Do you understand English? Or you don't understand? Ni Fatimi, lagi seorang. Okay, put your picture. Wan Zaidatul. Put your picture. Ni lagi satu. No Atirah. Sharifah. Apa ni Sharifah Nurul. Okay, letak picture lah. Okay, so that I know my strengths. I know who you are. Or kalau, you know, to do better, you turn on the video during class. Okay, what is the MPY? You got it? You don't have to tell, you don't have to say. I just want to know, have you written it? Have you?
Yes, sir.
Okay, good. So that is the MPY, all right? So you must be able to describe. Okay, now what we want to do next is, since we are talking about marginal productivity, okay, marginal product, that means you increase 1 input. What is the increase in the output? You increase 1 input by 1 unit. What is the corresponding increase in the output? So from there, you know the productivity, okay? You know, that's why they call it marginal productivity. You know the productivity of that particular input. What is the increase in the output? So the increase in the output is important, okay, in terms of production. So if you look at the MPX, if we increase capital by 1 unit, what is the increase in the output? 390.6. On the other hand, if I increase labor by 1 more unit, if I hire 1 more worker, what is the increase in the output?
59.65.
59.65. Now, which give you a higher increase in output? Labor or capital?
Capital.
Capital lah. Capital 390. Labor 59.6. So, which input is more productive?
Capital.
Capital lah, more productive. Because capital, you increase by 1 more unit, the output increased by much higher, by a higher amount. Okay, 390. If I hire 1 more worker, the output is only increasing by 59.65. if I hire one more capital, the output increased by 390.6. So capital is much more productive. Okay, you look at the value, they are higher by I think by more than double. It's berapa time ni? 6 times, okay, maybe 4 times. So that is marginal productivity. Okay, is a measure of productivity of an input by just looking at their derivative. Okay, all right. So another example that I would like to look at is example number 5 and example number 6. Okay, example 5, example 6, these are on the demand function. Okay, here you see the demand function. The demand for one good is dependent upon the price of 2 goods. Okay, the price of 2 goods. So this part I'm not going to cover in class. I want you to read. Okay, I want you to read the kind of function. I would like you to understand also the concept of competitive. When you take the partial derivative, then you can relate to whether the goods are competitive or the goods are complementary. Okay, competitive or complementary. So you look at the partial derivatives. So that is example 5, example 6. In my book, okay, in my book edition number 11, the pages is 878 to 879. Okay, so just read that page, not that much. All right. Okay. Now, what is complementary? Now, if you look at 2 goods, this is just economic, okay, economic discussion. If you look at 2 goods and they are complementary, what does it mean? Complement. When the 2 goods are complement, what does it mean?
Collateral.
What?
Collateral.
Collateral?
Something like extra,
Collateral. Meaning, if I got you right, it's being used together. Okay? It's
Yeah.
not collateral. It's collateral means you guarantee one another. Yeah, something like that. They use together. Okay? You cannot use one without the other. Okay, so they are used together. Okay, what is an example? What is an example of 2 goods that are used together?
Like
Pencil and ink.
Pen and ink. Okay, you cannot have pen without ink. You cannot write. If you just have ink without pen, again, you cannot write the way we write. Okay, so this is one complement. You have also, let's say, fuel, petrol, and cars. Okay, that are using together. Now, competitive is the opposite. Competitive means what?
Substitute.
Competitive means substitute. You have one without the other. Correct? You can use one in place of another. Okay, so competitive is like substitute. It's actually substitute. All right. The 2 goods, same purpose. So you can use one, not the other. All right. So example of 2 goods that are substitute. Apa dah?
Pencil and mechanical pencil.
Yeah. Okay. So you have the traditional pencil, okay, the lead pencil, and then the mechanical pencil. So they serve the same purpose, right? So they are substitutes. Okay. All right. Ada lagi apa? Cukup dah tu. So these are the example 5 and 6. Now I'll give you some questions for 4.3. I'm sorry, 14.3. To do question 2, 4, 8, 13, 14, 22. Now for question number 22, the question I would like you to answer not the way the book asks you how to answer. I want you to answer the book as per our discussion, right? So for that question number 22, I want you to do the derivative or the computation of the level of output at 1024. Okay, so X is 10, Y is 24. So here, the X, the capital is in unit, all right, not in dollars. And then the labor is just number of workers, okay, just like what we were doing. And then you have the output. I want you to answer, okay, answer the part A as in the book. So MPX, and then B, the MPY, and then C, the value of Q, okay, which is equal to Z at that point. Okay, itu je. You don't have to draw because the book say you may draw. So not draw the graph is quite difficult, 3-dimensional. So don't worry about the graph. We just worry about the meaning, okay? The meaning of this thing. Okay, so that is for question number 22. Okay, any question, anything? Okay, all right. So that's it on 14.3. So now we are going to move on. I have a few more minutes. We're going to move on to 14.4. Now 14.4 is about the second partial derivative test for maximum and minimum. So the idea is just like the second derivative test for maximum minimum, the case of one independent variable. So that would be the discussion on 14.4. So 14.4 is the second partial derivative test. So I just make it short, just second derivative test. We know, okay, we know it because you see the function will be having more than one independent variable. Second derivative test for maximum and minimum. All right. So to get the idea, I want you to look at figure 14.8. Okay, 14.8, there are two pictures. One is A, the other is B. All right, I want you to look at the diagram, study the diagram, and then we're going to discuss about that diagram. In terms of what? In terms of the critical point and in terms of maximum and minimum. Okay. Ini dekat tempat saya ni dah hujan dah. In your place, hujan ke panas?
Panas.
Panas.
Rain, sir. Nearly rain.
Dekat Gombak ni panas. Hujan. Ni
UAE
dekat
hujan.
UAE hujan lah sebab kita sama, saya pun Gombak lah. Dekat belah timur, dekat Pahang, Terengganu, Kelantan ni panas ke hujan?
Sarawak panas.
Panas. Dekat mana panas?
Sarawak.
Sarawak. Sarawak panas. Tadi panas juga, sekarang hujan. So nice, cooling effect. Alright, you look at the diagram. Okay, AB. Now, what does A tell you compared to B lah? Okay, look at the diagram. I want to write down what do you see from there in terms of maximum, minimum, things like that. Okay, number one, what?
Maximum.
Maximum, where is maximum? Which one is maximum?
A.
You see here, A is a maximum, all right, because you see the maximum point, and B is the minimum, okay? So that's number one. Number two, if you look at the two functions, you know, at the maximum point, at the minimum point, what do you see? Okay, what do you see? At the maximum and the minimum, what do you see? What do you see in both pictures?
A
There
plane.
is a line.
The what?
A plane.
You
Has-
see a plane, okay? You see the plane that is shown by the yellow plane, right? So you see that in A, you also see that in B, all right? Now, what else? What else do you see on the plane? Not aeroplane, okay? This plane, yellow plane. You don't tell me the name. You know, you don't have to tell me the name. You just tell me what you see in plain language. Hey, what is it? What did you see? You will see, okay? You see there for the picture A, you will see two horizontal lines. I draw in red. Now, similarly for the B, okay? For the picture B, where you have the plane, the yellow plane, that is at the minimum point, you also see what? Two horizontal lines. Now, what are those lines? Okay. Now, when you see lines for the curve, that means a straight line. That means these are the slope. Okay. So these are the partial derivative, fx, fy. Okay, the partial derivative. You know, remember the partial derivative. The derivative is what? It's the slope of the straight line just tangent to the curve. So similarly here, the partial derivatives are the slope of the straight line tangent to the curve at each of the independent variable. All right. So you have two. I have fx, fy. All right. Now, which one is fx? Which one is fy? Fx is the one that go along the x-axis. So fx will be this one. All right. Fy is the one that go along the y-axis. So that is fy. So you got fx, fy. Now, what can you say about the fx and fy at this yellow line, at this yellow plane in both AB? Now remember, for the slope, if the line is horizontal, what about the slope? What can you say about the slope?
Zero.
Zero, okay? If the line is, for the slope, if the line is horizontal, that means the slope is zero. So here, the fx is zero, fy is zero. The same is also true for minimum. Fx equal to zero, fy equal to zero. So in order for the point to be maximum or minimum, first thing that must be true is what? Is fx equal to zero, fy equal to zero. Okay, and that is what you call the critical point. Just like the critical point of the one that we did earlier. You have the fx equal to zero. But now there are two independent variables. So fx equal to 0, fy equal to 0. Okay, all right. So I think I will stop here. I give you some questions, for you to practice. That will be enough question. Okay, and then and on Wednesday, I will continue from here. Okay, all right. Any question? Any comment? So be reminded that the test will be 2 weeks from now. Okay, next Sunday on the 9th. So we have ample time to prepare. I don't give you 1 week notice. I give you 2 week notice. So enough time, before you actually have the test. So that's it for today. I'll see you again. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Have a nice fast iftar. Have a nice iftar. Okay, nice berbuka puasa. Okay. Assalamualaikum warahmatullahi ta'ala wabarakatuh.
Thank you, sir.
Thank you, sir. Have a nice
Thank you,
evening.
sir.
Sir.